Welcome to the CoSpace Robot family. Today, we'll be introducing you to CoSpaceRobot GP. CoSpaceRobot is an official platform for both RoboCupJunior Rescue Simulation and RoboCup Asia-Pacific CoSpace Challenge. Please visit our website to find out more.
In this session, we will give you a step-by-step guidance to the CoSpace GrandPrix. We hope it will help you to have a better understanding of the platform and take part in the CoSpace GrandPrix Challenge U12 category.
Line following is probably the most common application in robotics. It is widely used in industries and even hospitals. If a robot can think, the thought process of a line-following robot will be very similar to that of a human being. And that can be simplified into 3 actions: sense, plan, and act. CoSpaceRobot will give you a unique first-hand programming experience in such applications. Let's take a look at the CoSpace Virtual Robot. It is equipped with one color sensor to sense the floor RGB color, which is a short form for red, green, and blue. One gyro sensor to sense the robot's orientation. One ultrasonic sensor to sense the front obstacles. And 6 infrared IR sensors for line tracking. What is the logic behind the robot's thinking process when it tracks a black line? The 6 IR sensors mounted on the robot are like 6 eyes of the robot. When the first left IR sensor, we call it L1, senses the black line, the robot needs to move forward. When the first right IR sensor, we call it R1, senses the black line, the robot also needs to move forward. When L2 senses the black line, the robot needs to turn left slightly. When R2 senses the black line, the robot needs to turn right slightly. When L3 senses the black line, the robot needs to turn left rapidly. When R3 senses the black line, the robot needs to turn right rapidly. This process repeats forever in a loop, and this will ensure that the robot tracks the black line. Let's code a line tracking program in CoSpaceRobot.
For optimal performance, your PC/laptop should meet the minimum configuration. The Microsoft Robotics Developer Studio and CoSpace GrandPrix Simulator must be installed in order. Let's watch a video guide on installation.
Hello, good job. We are almost there. Let's click on the Experience button to see if our computer is compatible with this software. While we are at it, let's also check and see the version of our software. It's always good to have the latest version. Awesome. It seems that our computer is compatible and our software is up to date. And now it's time to activate our software. So there are 3 options: Learn, Compete, and Experience. We're going to click on Learn. First steps, there's a workshop and iCool. Intermediate, there's also workshop and iCool. Advanced, workshop and iCool. So for this example, we're going to use first steps. Alright, we're going to click on Workshop Pack 1. The activation window has just popped out, so please make sure you're connected to the internet and input your account number, as well as your serial code, which is also your license number. So these will be given to you via email, so please make sure to check your email. And also please make sure when you put in your serial code, there are no spaces in the front and at the back, because the serial code is case sensitive. And if you're having trouble with the software, you should right-click on the icon and click the Run as Administrator option.
Double-click CoSpace GP icon on your desktop. Now, choose the level and map, which is also known as the virtual environment. In this tutorial, we will choose Carnival for illustration. To adjust the virtual environment, first, click anywhere in the virtual environment and then press the Q, W, E, A, S, D keys to adjust the 3D view. If you press Shift plus the keys, it will make the movement faster. If you are lost, press Home key. To manual control virtual robot, first, click anywhere on the control panel and then press the 4 arrow keys to move the virtual robot manually. While the robot is moving, you can monitor real-time data from sensors mounted on the virtual robot. Well done. Let's move to the next section.
Double-click on the CoSpace GP icon on your desktop. Now, choose your level and map, which is also known as our virtual environment. For this video, we'll choose Carnival Practice Field. Double-click on the AI button to enter the programming interface. First of all, you will need to create a new project. Click on the New Project button. Please remember to give this program a team ID, a team name, a project name. Remember, once team ID and team name are confirmed, they cannot be changed anymore. However, you can change the project name if you wish. Based on the analysis earlier, we now need to convert the logic into code which the robot can execute. The first statement should tell the robot that when L1 senses the black line, the robot needs to move forward. Step 1. Create a statement named L1 senses black line. Step 2. After the statement name is defined, we'll add conditions to this statement. We'll click on L1 until it turns black in color. Now this means L1 will sense for the black line. Step 3. We should tell the robot what to do when the condition is met. In this scenario, the robot should move forward. That means both wheels should have the same speed. Step 4. Finally, click on the Preview button to see whether you have set the correct wheel speed. Great! We have completed our first statement. Repeat the 4 steps above to complete statements 2 to 6. Statement 2. When R1 senses the black line, the robot moves forward. This is similar to statement 1. Make sure we have set the same speed for both wheels. Statement 3. When L2 senses the black line, the robot turns left slightly. This time, we will set different speeds to the left and right wheels. As the robot turns slightly, the speed difference should be small. Same concept applies to statement 4. This time, the robot turns right slightly. Statement 5. When L3 senses the black line, this means that the robot is almost off track. So the robot needs to turn left quickly. This time we can set the left motor speed to be negative and keep the right motor speed positive. Same concept applies to statement 6. This time the robot should turn right quickly. After we have completed our program, we should do a quick check that the logic is correct and make sure every statement has conditions and actions. Once you have completed programming, it is very important to save and build. Save means to save the most recent program that you have just completed. Build means to check for syntax errors, create a C code and a dynamic data link file with extension DLL. Now you can click on the trial run button to see how the robot will behave. If you wish to modify the program, click on the Stop button and you will go back to the AI panel to modify the program. You can load the DLL file and monitor the robot's performance in the control panel. We can use the play, pause, and stop buttons to control the robot's movement. We can also change the viewing perspective from the menu bar. The AI camera gives a helicopter tracking view or a bird's eye view. The front camera gives a driver's view or a first-person view. We can also put together multiple viewing windows, and a common practice is to keep the overview in the main window and set the front camera in a small window on the side, so you can take a look at details as well as have a good overall picture of what's going on. When the robot reaches the finishing line, it stops, and the time it took to reach there will be recorded. Well done! You have completed the line tracking robot program.
Let's work on the Challenge 3 on Secret Garden. You should launch the Challenge 3 field. The task for Challenge 3 is to program the robot car to travel in the secret garden. The robot car starts its journey from the start station. It must pass through all waypoints before stopping at the destination. To complete the task, the robot needs to track the black line, avoid obstacles, detect floor colors and make correct decision. The RGB sensor is mounted at the front right corner of the robot, facing downwards. It outputs the exact color as it detects, in terms of the red, green and blue light intensities. Each channel value can range from 0 to 255. The RGB sensor gives 3 readings for each color detected. They are the corresponding red channel reading, green channel reading, and blue channel reading. Just like programming other sensors, when program the RGB sensor value as a condition setting, you have to specify a range for all 3 channels. Now you can write a simple code for this task. You can specify different time segment, and then, let the robot to take certain action within certain time frame. Using timing is the first technique we need to learn. You may take Challenge 1 as reference to program the robot to complete the task. We can also program the robot using state. Let's specify the robot as in state 0 before it reaches blue marker. It will be in state 1 after passing the blue marker. In state 0, robot turns left when it senses red marker. In state 1, robot turns right when it senses red marker. State variables can be used in both condition and action. Same as other sensors, when using state and condition, you need to specify a range. Launch the Challenge 3 and write your own code using state. This is the sample code. I am sure you can write a better one. Well done. Let's move to the next section.
RCAP CoSpace GP Challenge Rules, U12 category. This category is for students aged 12 and below. Welcome to the RoboCup Asia-Pacific RCAP CoSpace Challenge. Automation of routine tasks is currently a concept that interests many industries. Among the most revolutionary parts of it are autonomous vehicles. These are visions of the future of city infrastructure. The main ideas they all share are self-driving cars and shared mobility. Those are set to revolutionize the ways we navigate through cities. In CoSpace GP Challenge, teams are required to build a real robot, develop and program appropriate strategies for both real and virtual autonomous robots to navigate through both real and virtual worlds. For the IQ Challenge, participants need to program an autonomous car to navigate in a smart city. The autonomous car needs to pass multiple waypoints before reaching its final destination. In this smart city, there are roads, buildings, color markers, black and white lines, and waypoints. In the iCool challenge, there will only be a virtual robot. The robot has an IR sensor array, an ultrasonic sensor, and a RGB sensor. Students need to utilize the elements in the smart city to plan the best path and program the robot accordingly. Let's take a look at the game process. The duration of the game is 8 minutes. That means the robot has to complete the whole journey within 8 minutes. At the beginning of the game, the virtual robot is placed at the start station. When it travels towards the finish line or end station, the robot must pass all waypoints in any sequence. It does not need to stop at the waypoints. The game ends when the virtual robot arrives at the finish line in the virtual world. If the virtual robot passes all waypoints and reaches the finish line, the team rank is determined by the race time at the finish line in the virtual world. If the virtual robot is not able to pass all waypoints, regardless whether it reaches the finish line or not, the race time for the virtual robot to reach the last waypoint will be recorded. The team rank will be determined based on the number of waypoints passed, followed by the race time.
The detailed rules can be found in RoboCup Asia-Pacific official website. If you have some experience with programming or have completed CoSpace GP FirstSteps, CoSpace GP U12 is designed for you. After finishing CoSpace GP U12, you can move on to study more advanced contents in CoSpace GP U19. There will be 2 videos in this sharing and highlighted games section, one from 2 of the 3 CoSpace GP series categories.
I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from me.
Hello, my name is Donghyun Kim. I live in South Korea, Anyang. I am going to participate in RCAP CoSpace GrandPrix Challenge U12. I've been learning robot engineering since I was 8 years old. When the grounds are all back, the car goes forward. Sometimes it does not work in the right way. That's the reason why I set a time to change the direction of the car. Also, there was a very hard part on the map. The car has to find a line and turn around, but I don't know how to find the line, so I put all the possibilities into my program. It was a little difficult. When I first practiced the CoSpace, it was like a game. As the time passed, it became more difficult because I had to program ultra sensor and color sensor too. However, I'm willing to learn more about the CoSpace. It's very exciting. Thank you for listening to my speech. Bye-bye.
Part 1. When ultrasonic sensor sees obstacle, I program to swing turn to right. Part 2. Between 14 to 19 seconds, when floor is all black, I set to turn left. Part 3. I didn't program things, but it just go forward. Part 4. Between 25 to 28 seconds, I make it turn right. Part 5. I made the car to go straight between 30 to 33 seconds because when I didn't program it, it didn't go where I want. Part 6. Between 34 to 37 seconds, when ultrasonic sensor sees obstacle, I set to turn right. Part 7. Between 40 to 43 seconds, when ultrasonic sensor sees something, I make it to turn right. I don't know why I have to keep turning right when ultrasonic sensor sees obstacle. Part 8. Between 56 to 60 seconds, when ultrasonic sensor sees something, I set to turn right. This part is the last part of the ultrasonic sensor using. Part 9. In this part, I really didn't program anything. I am not telling a lie, it just go right. Part 10. Also no program. It's so a line and trace it. Part 11. This was so much hard I put all of my effort in this part. So I set to turn between 77 to 81 seconds, but it didn't work, so I fixed it by programming all the number of cases on it. Part 12. Last, I programmed to turn when floor runs all black between 96 to 98 seconds.
And we're off! The robot has left the starting point. And we have passed our first waypoint. Wonderful path planning. Keep going. Second waypoint. Third waypoint. Awesome! Great turn. Keep going. Fourth waypoint. Keep going. Wonderful path planning. Awesome. Great turn. Keep going. Keep going. Fifth waypoint. We are now halfway done. Keep going. Awesome. Great turn. Keep going. Great shortcut. Keep going. Great shortcut. Awesome. Great turn. Last waypoint. Almost there. Keep going. Almost there. Keep going. And we have crossed the finish line. Great job! Congratulations! Challenge completed.
I'm a game changer. I'm a risk taker. I don't hide from the battle. The battle hides from me.
Hey everyone, my name is Alicia and I'm one of the participants representing Singapore in the iCool Challenge under the U19 category. I am also known as participant SG3055 and this is my presentation. So more about me. Despite representing Singapore in the iCool Challenge, I was actually born in the Philippines. And to elaborate further on my robotics experience, I have 5 years of experience with robotics, which is basically a third of my life right there. And in addition, I am a student with homework, believe it or not. And, well, whoa. Hold up there. I may or may not miss a detail here. And that's this. Yep. This is me. This is my face. Don't mind the filter, alright? Well, it's nice to meet you. Alright, thank you for your time. Moving on to the next slide. So, as a student with homework, it means that I go to school. And since I go to school, I have co-curricular activities, also known as CCA, which was first introduced to us in primary school. Well, you see, I first stepped into the wonderful world of robotics in 2015 when I was in primary school, and after at least a year of lessons, it really changed the way I view the world. Like, 10-year-old me would just sit there, think about how machines and devices work, and what was the logic behind them. However, everything changed when I stepped into secondary school in 2019. So, back in primary school, we were taught Lego Mindstorms and everyone's favorite coding software, Scratch. So when I got into secondary school last year, I went for the CCA trials and managed to get in. Then that's where my experience with CoSpace started. In the same year, the whole of the robotics club was sent for a RoboCup competition. And it became my very first competition in RoboCup. I'm not gonna lie, it was stressful, and believe me, it created a whole new level of tired. But hey, it was all worth it in the end. Like, sure, programming is mentally exhausting, but once that program of yours starts moving, no one else can understand your happiness and joy. Like, seriously. One thing I've learned from CoSpaceRobot is that variables are one of your best friends in programming. In fact, I've developed a motto for myself when I'm doing work. When in doubt, use variables. And what I've gained through the iCool challenge are two things. One of them is the experience, because I will never forget the moment when the virtual robot crossed that finish line. I have actually never been happier that day. And the next one is kind of a two-in-one thing, but I would narrow it down to realization. My video on the RCAP Academy YouTube channel made me realize how supportive my family, my friends, and my school are, and I felt very, very grateful. So after watching the videos on the first season of the iCool Challenge, I concluded that one participant I'm most interested in is participant SG3021. She mentioned that she used functions in her program, and her robot managed to fulfill all the objectives in under 2 minutes. In under 2 minutes! That's... my goodness! I am not very sure what functions are, but I definitely want to learn more about them from her. I'd want to be able to share my knowledge on robotics to those who are very interested in learning and or want to know how to solve a problem in their program. I feel like sharing knowledge with other people and teaching them will not only benefit them, but also you, as it can help you polish your existing knowledge and abilities, making you better at what you do. The next part of the presentation will be on video analysis, and I'll see you there. One strategy I used in my program is following the lines on the roads of the map. There were some areas which were terrifying because the robot was at least a centimeter away from falling off the road. But hey, it all turned out okay in the end. Not to mention the roads that didn't have lines, but I'll get to that later. So for line following. There are 6 sensors underneath the robot. The robot is programmed so that if one of the sensors senses white, it will turn to move to white in its direction where it was sensed. Repeat that code for all 6 sensors and boom! You've got a robot that follows lines. Or in this case, the road. As for algorithms, I basically have variables as some kind of counters, which would count, for example, how many checkpoints and reds the robot has passed by. For example, on this red, the default for red is to turn left. However, once it reached the 3rd checkpoint here, which you can't really see, the variable checkpoints would have been changed to 3. You couldn't really see one of them too, but there are also 2 reds in these positions. However, in the reds, the robot would have to turn right instead of left. So I coded it so that once the robot reached the 3rd checkpoint, the next 2 reds would make the robot turn right instead. You might have noticed the little red sitting over here. Well, it's pretty much the same thing. Once the checkpoints variable says, "Hey, we made it through all the checkpoints," and so I coded it so that the robot reaches the final red, it will turn left. One of the problems I've encountered was this little bit here. You have no idea how long I've stared at my screen, trying to figure out how much speed the 2 wheels of the robot should be set to achieve that perfect curve. But, after hours of burning my eyes, I ironically noticed a little detail. I don't know if you've noticed it already, but you see, the walls or outlines on this road are at least 4 times as thick as the other roads. Then it came to me. I don't need a perfect curve. I need to wall ride this thing. And oh boy, everything became clear to me. I changed the programming so that when it sensed yellow, it will change to a kind of reverse line following code. So like if it sensed white, it would avoid the white line instead of going into it. I was unbelievably happy when it worked, that I started having some mini celebration in my head. We have come to the end of my presentation. Thank you so much for your attention. This was Alicia, or participant SG3055, signing out. Have a good day, everyone, and stay safe.
And we're off! The robot has left the starting point. And we have passed our first waypoint. Wonderful path planning. Great shortcut! Keep going! Awesome! Great turn! Second waypoint. Awesome! Great turn! Wonderful path planning. Third waypoint. Keep going! Wonderful path planning. Keep going! Awesome. Great turn. Fourth waypoint. Wonderful path planning. Oops. Awesome. Great turn. Fifth waypoint. Nice U-turn. So much time saved. We are now halfway done. Keep going. Oops. Wonderful path planning. Awesome. Great turn. Keep going. Seventh waypoint. Keep going. Almost there. Keep going. Last waypoint, almost there. Keep going. And we have crossed the finish line. Great job! Congratulations! Challenge completed.
Like to view more sharing and game videos? Visit RoboCup Academy YouTube channel.